Okay. It's asking me a question, so
I
that's
don't have to
why.
give you permission to do it, right? You can.
Mm,
I don't think so.
Will Google allow you to share your screen? Hmm.
Hmm.
Well, I mean, that's okay. We can work
Oh
without it.
no!
If
Was it
we
not
have,
working? Is it anything on my end that I need to do?
I think it might just be on my end. I don't know why. You must grant permissions in order to share the screen. It won't let me window. Let's see. Yeah, Firefox won't let me share my screen
Oh,
for
yeah,
some
yeah,
reason.
yeah.
Yeah.
People have been talking about how Chrome is sort of, in order to use all the functionality of Google Meet, you got to use Chrome.
Oh, okay.
Did you want to switch or do you want
Yeah,
to
let
just
me
hit
see if
the?
I can just quickly log out and then log back into Chrome. If
All
I,
right, let's do that.
all right, thank you. Chrome.
Anybody eating anything good for lunch?
I haven't even had breakfast.
Oh no,
Does popcorn count?
popcorn's good.
I mean, I'm having Italian sausage, broccoli,
Oh,
cauliflower, and Brussels sprouts.
well, that sounds good.
Yeah, it is. We had it for dinner last night, so
Nice.
it's leftovers.
Uh, all right.
Well, this is
There
looking
we
better
go.
already. Let's
Yes.
see. Okay. Can you see my presentation now?
Yes.
All right, good. Okay, so what does it take to be a crash test engineer? Well, I'll give you a little bit of my background. Education wise, I grew up in the Midwest, so that's why I went to Big Ten schools. I have a bachelor's degree in mechanical engineering from the University of Wisconsin. When I was there, I was part of the hybrid vehicle research group where we changed a real big, regular sales vehicle into a hybrid vehicle and competed against other schools. I also worked on research projects on eco-friendly refrigerants and compressors and heat transfer properties in motor designs. I wanted to learn what part of mechanical engineering I was really excited about. And so I tried a couple different research areas. Then, when I got my master's degree at Purdue University, also in mechanical engineering, I had discovered I really wanted to work on biomechanics, which is the study of human injury tolerances. So you learn how much strength does it take to break a bone or to tear a ligament or things like that. So it's a little bit between mechanical and also biomedical engineering type things. While I was there, I worked on sports injury research, spinal implant technology, and a medical bed optimization for reducing injuries. I received an opportunity to work at General Motors during my master's degree. It was due to the experience that I had on the hybrid vehicle team. It caught the attention of some of the hiring managers at General Motors that I seemed to be a team player, somebody who was really excited and interested in the field, and was learning all sorts of new things that maybe eventually I could become an employee at General Motors. And I specifically asked to work in the vehicle safety and crashworthiness division because I had started to understand that I was interested in this biomechanics area of mechanical engineering. And I was placed in a group that worked on frontal crash protection for the Hummer H3 SUV at the time. And so I got to see some actual crash tests, which was super cool, like, obviously really amazing. And I was able to do some modeling and learning about what parts in the car are all used to protect people inside. I got my first job coming out of college at Transportation Research Center, which is a testing facility out in the middle of Columbus, Ohio, near the Honda facility out there. And I worked with the DOT, NHTSA, to work on future safety regulations for cars. So new dummies, new types of crashes, and how they might be implemented into new ratings and new regulations in the future. And after working there for a short amount of time, I found out about this job opening at the Insurance Institute for Highway Safety. And it had been my dream since becoming interested in biomechanics to work for the Insurance Institute, because I think, as you may have heard of us or heard from us, we're typically on the news with our IHS Top Safety Pick Awards, our crash test ratings. They're on ads for every manufacturer. You see ads on TV and all of that. And so they're kind of the premier place to do this kind of research where we can run car crash tests and improve the safety of cars for people on the roadway. So what do I do as a senior research engineer? I do research based on real-world crashes to try to develop new crash tests. And I've worked on frontal crashes, side crashes, brain injury research, new dummies, pedestrians, and bicyclists, and who knows what I'll be working on next. Basically, I work on a project learning about the real-world problem and trying to figure out whether we can make some sort of laboratory test to assess vehicles, see if vehicles can get better, and then look back again at the real-world data and understand, did we do a good job of making this test and vehicles safer on the road? Big part of what I do is writing research papers on each of these steps through my process. And a lot of these papers are presented at conferences globally. And so I've had the opportunity to go to Japan, Korea, Ireland, Spain, all sorts of places with this research that I'm doing, and present to all these really, really, well, intimidating, but very experienced people that have been working on car crash testing even since the 1950s to make vehicles safer. And it's really exciting to learn from some of these experts as well. I get to also speak to the public about our research and how it affects people's lives. And this is maybe a more unique aspect of my job than the typical engineer, but it's something that I want you to keep in mind in the work that you will do in the future, is that we need to make whatever we're doing, whatever we're developing, that's so science-focused, accessible and understandable to the general person. Because if you come up with the greatest invention in the world, but you're unable to communicate to people how this affects them, what does it mean for them, then your invention won't have the outreach that you mean for it to have. It won't be as meaningful to the bigger picture if people can't figure out what does it really mean for them and what does it mean for the global good. So that's something that I work on as well. Our company is an independent scientific and educational organization. And if you have been, or I'm giving you a virtual tour right now, this is what our facility looks like. We have a big main building with offices in the front. In the back is our crash test facility. And you see a giant dome structure. And that is where we're doing a lot of our crash avoidance technologies now. So we have things that we can drive vehicles around and learn about how to prevent crashes instead of just dealing with crashes that are happening. So here's the crash hall. Here's where all of the action happens. And we're able to run 2 full-size pickups into each other at 50 miles an hour We can also switch out different parts in the middle. So we can do, head-on crashes, side crashes, crashes into a barrier or into a pole or a fixed wall, all sorts of cool things. So whatever we learn from the data is something that we want to run a test for. If we can justify it, we have all the capabilities to run different kinds of crashes. So as I had mentioned before, this is the process that I tend to follow as the lead of developing a new crash test. We look at the real world problem. We try to replicate that problem in the lab as best as we can. So if we're replicating two cars hitting each other, we're going to buy those two cars and we're going to try to estimate the speed, estimate the impact location, try to match it as much to the real world data that we have and run it in a controlled environment. We're going to learn some things about that. And then we're going to say, how can we simplify this condition to create more of a repeatable test? So there won't always be a Honda Accord hitting a Toyota Camry. But how do we make a test that represents this car being hit by an average car of a certain size or something? Once we come up with a new test procedure, we then rate vehicles, and we want to have a range of performance. We want to see that one vehicle is doing a really good job and other vehicles have some work for improvement. And the goal is to get those that we recognize as needing improvement to make improvements so that every one of these cars has the same high level of protection in whatever kind of crash. We then have to sit and wait, be really patient, but we'll be able to, in a few years after a new test comes out, revisit that real world data to determine, were those ratings effective? Did the things that manufacturers put in their cars make a real difference in saving people's lives? So I'll give you an example of one of my projects. Was a new frontal crash test that we developed in 2012. What we noticed is that a quarter of the crashes in real world crashes were in this, what we call a small overlap crash. So only about a quarter of the car hits another object. So it's almost like you're side swiping. And what we noticed is that vehicles that are doing really well in our existing front test were sometimes complete failures in this small overlap condition. So on the left, we have our original front test. Car did really well. That same model of car was completely destroyed in this small overlap crash. Okay, this rings a bell for me as an engineer. This is an area where maybe improvements can be made. What can we do to make a new test that would challenge that vehicle to do better? And so again, we look at some more real world data, and there are groups that collect information on real crashes in which real people are being injured and killed. And so we look at this data and we kind of categorize. We put them into different bins. Okay, here are the 3 kinds of crashes that seem to be happening. So take that real world data and run some example tests. So we ran a test where we had 2 vehicles, again, kind of coming at each other, but sideswiping. We had another kind of crash where the vehicles come in at an oblique angle. And a third kind of crash where you hit a tree. And so we had an example tree. And in all of these, you can see, huge damage to the vehicle. So again, promising that this test could tell people, here's how you need to redesign your car. The most important point that we learned from doing all 3 of those crashes is that the same parts of the car were getting damaged in all 3 of these crashes. So we could create one laboratory test that challenges those same structures and promotes improvement. Base our ratings test off of. Well, as part of a design process, you're going to look at a range of things. And so we had 4 different barriers that we wanted to try out, running the car into these barriers. And we had certain goals that we were looking for. We were looking for a certain amount of damage and a certain amount of movement for these vehicles that will replicate those real vehicle crashes. And I call this the Goldilocks Method. We have a whole range of crashes that we're going to do. Some are going to be too little. Some are going to be too much. And one of these is going to be just right. And that's exactly what happened, is that we had this range of 4, and we came to the conclusion that the one that we're calling the flat 150 was the perfect balance of getting us the right severity and the right amount of vehicle motion. And so this was our final test. We released this as here's the final test mode, and we started rating vehicles. So we have initially, again, this range of performance where we had 11 vehicles. Only 2 of those 11 got our highest ratings, and actually 8 of those 11 got our failing grades, saying, okay, a lot needs to be done to improve performance in this new test. Here's another fun video of the range of performance that we're seeing. So the vehicle on the top did really poor. You can see it just crushes. And the vehicle on the bottom held up really well to that test. And we also noticed problems inside the vehicle where, like, the airbags aren't able to provide protection. So in one case, the dummy's head slides right off the airbag. And in the other case, the dummy stays on the airbag and is protected. So we set up this award to promote competition, to say that their car has won more awards, is the safest car out there, all of these things. And so, Honda versus Toyota are going to be out there competing to have the safest car and the best ratings. And because of this, you notice that ratings have gotten better over time. And when we first started, there were only a few vehicles that got that good rating, and now everyone gets a good rating. So where are we in this path? We identified a new kind of frontal crash test, real-world problem. We ran some lab tests that replicate the situations that we're seeing. We simplified it into a test condition that we could then do ratings. So then we started rating vehicles, and we're seeing improvements in ratings on those vehicles. Now we're in that final stage where we have to have lots of patience, where we need to wait for more real-world data to come out on those vehicles so we can go back again and determine just how good of a job we did at protecting more people in the crash. So most of the projects that I do follow this kind of procedure. Now, this takes years. I made it sound like I did this in the snap of a finger, but this is the process that I've done for basically all of the tests, all of the different test modes that I've worked on. And it's really neat to see it get to go through this process and get to that final stage. And recently, some of the results that we've gotten on other projects in this final, revisiting how effective these tests are, is really amazing and promising numbers. And it's awesome because it means that real people are walking away from crashes when they wouldn't have. So I'll talk a little bit more informally about my day-to-day job, but I did want to talk about a few words to live by, things that I think are really important to keep in mind. And again, communication skills, I think, is really an important part. We didn't become engineers because we like to talk and we like to write papers and we like to do those things. No, we became engineers because we like the science, we like the experimenting. But we have to be able to find a way to communicate what all of this means for people. You're going to develop something and it's going to be an absolutely amazing scientific discovery. But to be able to tell that discovery to your grandma and have her understand it is what is a skill that really we need to work on. Communication is pretty much, in everyday life, so important. And communication will be essential for you to really making your products or making whatever you're doing be meaningful on a bigger level. The second thing I want to tell people is don't be afraid to fail. You are going to get results that you don't expect, but that doesn't mean it's a failure. When I talk about the Goldilocks method of finding a final barrier, there are times that it's more than 4 things that we're looking at. There are times that I'm absolutely convinced, would bet money that this next test that we run is going to be perfect, and it's a complete flop. And you have to go back to the drawing board. And that's another really important part of engineering, is having the ability to accept the failure, but go back and keep trying, not giving up. Because it's actually about how you regroup and then move forward that will define your work. It's not about always having success the first time. And you think about all of these people that are considered to be great inventors, great scientists, like Steve Jobs and other people. They've failed countless times before they had their great success. But if they had just given up or said, I guess I'm not a really good engineer, I guess I just suck at this, and given up, they would have never gotten to that point where they had success. So you need to remember that even in schoolwork, that one bad class that just grates on you and you just cannot do heat transfer or something like that does not mean that you're not meant to be an engineer. It means you need to regroup, figure out the skills that you need to find within you or externally. Find tutors, find helpers, go to office hours, and do what you have to do to keep moving forward. The third thing is teamwork. Lift each other up. Don't step on others to move up. You're never going to get further in life by taking others down. You will get further in life by showing what your capabilities are and by bringing people up along with you. And in engineering, there are so many opportunities to work in a team environment. This is absolutely essential. I mean, you'll have labs and all sorts of other things where, there's times that you're the one holding up the other people. And sometimes that's frustrating, but that's life. And you got to get the project done. And sometimes to get it done right, it means helping others and being a team player, maybe more than you want. So with that, I will send it back to the video. Hopefully I'm back again. So if anybody has any questions for me, feel free to get started.
Jackson.
Can you hear me?
Yes.
Okay. So with the emergence of more like automated cars, self-driving cars, has the IIHS been either developing or has developed testing methods for the safety of those capabilities?
We are. So a lot of the work that we're doing underneath that dome structure that I pointed out is to be driving vehicles around in a controlled environment, but also we're going to be doing more testing where we take vehicles on roads and press those, level 2 automated buttons and see what happens and see in what conditions it works or doesn't work. And this is going to be a bigger and bigger part of the future as we have more of these systems. Another thing that's very exciting to me and will be useful in my latest project is a convergence of the pre-crash world and the crash world. So if cameras can identify that a crash is coming and it's 100% going to happen, they can deploy airbags and tighten up seat belts and prepare the vehicle and the person inside the vehicle much better than waiting for the crash to start and the car system to then provide protection. Great question.
Thank you.
Other questions?
What's the worst car you ever seen, like safety wise tested?
So it was a small overlap of a Nissan Quest minivan, and they had not prepared for this new test that we introduced. The front end split open to the point where the engine dropped out of the subframe. Like the engine was just laying on the ground. And we were like, wow.
Wow.
So it was pretty crazy.
And that's a minivan.
Normally
too.
we can at least get the forklift and pick the vehicle up and carry it away. And this one they were like, we're going to leave like the whole engine front suspension sitting in the crash hall. So we've had some really interesting ones, some really fun ones. You know, we keep in mind that there are real people affected. This does relate to that, but there's so much fun associated with just the crashing of the cars and destruction of stuff at high speed that you can't help but really enjoy some of the odd occurrences that happen.
Cool. Let's go to Sydney's question.
My question was, how often do you guys produce these new tests?
Usually every 3 to 5 years, we have a new test come out. We've always done one test because it takes about 3 to 5 years to do that from start to finish, real world data all the way to a new test. But we now have 2 teams working simultaneously right now. So in 2 years, we're going to have a new test that I developed and a new test that my coworker developed coming out at the same time. So that's going to be twice as exciting because it's more stuff for manufacturers to fix on their cars all at once.
And do you retire any tests?
We have not to date, but we are thinking of retiring a test in the future. Some of them, as I showed the one graph of all, how more and more cars get green. There are a few tests that cars have gotten green for many, many years, and there's really no way to upgrade that test. So we don't expect that anyone would get less than good. Maybe we can accept that is kind of the standard now.
Mm-hmm. Jessica, question.
I wanted to ask, because the projects do take so long, what are your hours like on a day-to-day basis?
I do still work a 9 to 5. Rarely would I have to stay late or things kind of be out of sorts. But my days are either a combination of being in the lab and being at my desk, or primarily being at my desk and putting together the results of tests. So
Gotcha.
Right now, working from home isn't a problem because I had just finished a test series before everything got closed up. And so I'm sitting at home analyzing a bunch of data from 8 different crash tests, all this, tons and tons of data, putting it together in presentations and papers and memos to my boss and those things. But when I'm done with that section, I'll need something new in the lab to kind of feed my next steps.
Right.
So I know we have a lot of questions in line, but can I actually just add to that question and ask, in this field of work, is there, I certainly have known some engineers who are in a field of work where there's a whole lot of pressure to produce some results and they do have to work long hours. In this field of work, is it just sort of you're just churning along and producing, but there's not a whole lot of pressure to get the results out fast?
Correct. Part of it is because it does depend on the team of people running the crash tests. So there's about a dozen people different backgrounds. So electronics technicians, mechanical technicians, some more advanced folks that run the crash machine, that coordinate, manage the whole test process. They can only work or move so quickly. We do 2 tests a week, and it's kind of a perfect schedule for people that can only work 40 hours a week, that they are not being pressured, but they're not bored by having, a Tuesday test. They're prepping on Monday, they're testing Tuesday. They're prepping on Wednesday, they're testing Thursday. They've got an extra day on Friday to catch up on other things. But they are more so hourly workers, so they can't work overtime. And we have found this perfect balance at our facility that allows us to keep the staff. We never have to lay people off when there's kind of an ebb and a flow of workload. It's nice and steady. If you like the TRC, the facility that I used to work at, that's a testing facility, they may be asked to work longer hours or at odd times of the day, depending on whatever kind of tests they're doing. There are some places that run 3 shifts per day of testing. And so they're able to test 6 or 8 vehicles a day, which is just mind blowing to me. But, but then they may have times when they don't have any tests. And if that time is long enough, they may be laying people off. Right. So, it depends on who you are in our industry. There's a lot of testing facilities that do have folks that work well over 40 hours a week. I guess I'm just thankful that I don't. So
yeah. Jody, question.
This question was similar to the last question, but are there any limitations to your personal life because of work? And how would you advise undergraduate students to plan their future because of your experience?
I think my favorite thing about being in a job versus being in school is the fact that when I go home, I go home. Or if I take vacation time, I'm on vacation. I found that especially in grad school, like you're sort of always on call to be working on your research or working on homework that's outside of class time. And the job environment is a lot more black and white, that you're either at work and doing work and not doing personal stuff. But when I want to go on a 2-week vacation to Hawaii, I don't take my computer, I don't take my phone. I'm not touching a bit of research while I'm doing that. But I guess it does depend on the job that you're in. I mean, I've had other friends of mine that I graduated with who are at companies that it's 50-hour a week jobs, and that's just the way it is. You kind of have to find the right niche of a place to work for that balances the things that you're looking for in life too.
Mm-hmm.
Great.
Thank you.
So, I think this might be a little bit repeating, but I think that you could probably say 1 or 2 more things. Mubashara asks, I'm just reading her question, do you have any particular advice for students interested in becoming engineers?
I recommend doing some internships or co-ops at a variety of places. Pick a small company and pick a big company, or pick a mid-sized company and a big company. And I think you will learn a lot about what size company, what company culture fits you as well, because it's not just about the major, but it can be a lot about the way that people interact with each other, the freedom or lack of freedom that you have. There are so many advantages and disadvantages to every kind of and size of company, that to figure that out, I think, is also a really important aspect. I mean, I worked at General Motors where we had I think it was about a 2-mile by 2-mile campus. And so they had little shuttles, little short buses that would take you around from building to building. And they had giant cafeterias and a medical center and a hair cuttery and like all of these things associated with having thousands of people working at one location. There were so many unique experiences that you could take part in a company that size that I certainly could not take part in the company that I have that has 100 people out in the middle of nowhere, with, certainly no cafeteria, but like 4 restaurants in town and that kind of thing. But, at General Motors, I would have had the opportunity to only work on my one little piece of one little project as an engineer. But you could become very, very well versed on details of that part of your job. In my job, because it is a smaller company, I'm able to wear a lot of different hats and do a lot of different things that just don't fit into the tree of employment that you would have if you were at General Motors or stuff like that. But you need to find out what works best for you. Where do you thrive? And where can you see more opportunity? Because there certainly isn't, in a small company like mine, opportunity to become a manager or opportunity for advancement. And they can't really pay for me to go back and get a PhD or go to a lot of continuing education classes. Everyone I knew at General Motors was getting a PhD or a master's degree paid for by General Motors and taking part in all sorts of continuing education. And they have a lot of other clubs and stuff. So I'm babbling, but you have to figure out what works for you. And I think the only way you'll be able to do that is by experiencing it all for yourselves.
Yeah, no, I think it's really good, because it's valid for all the science fields. It's not just valid for engineering. Absolutely. Just that difference between the big company and the small company and the feel of the place, et cetera. Anyway, Jude, question.
So where does IHS get their funding from?
We get them from insurance companies. They have money set aside for doing good. So you might hear about programs where they are, working with teen drivers to become better drivers, or they're working with older drivers, different kind of campaigns to make roadways safer. We're one of those kinds of things that they belong to. They work with us kind of like in a club mentality. So for $5,000, your mom and pop organization can claim that they're part of the Insurance Institute and come and see a crash test. For $10,000, you have a higher membership level and you can get access to different data that we have. For $30,000 a year, you get, all these other benefits. So about 95% of insurance companies like State Farm, Nationwide, Progressive, all contribute into this big pot of money. And they say, okay, go study ways to improve highway safety. And that's what we get to do. So it's my job to argue, here's the thing that I want to study, and here's why you should give me that money to do it.
Damien, question.
So my question is, how long do you typically spend in a lab, and how long, I guess, is the rest of the time you're not in the lab in a typical week?
I would say, well, it goes more in chunks of months. I might spend a month doing just analysis and then a month of doing testing. But for the times that I'm doing testing, because we've got 2 tests a week, I might spend about 3 days of the week in the lab helping set up, answer questions about how to set it up, watch the test, watch the teardown, get some data there. And then the other 2 days I'm spending already analyzing and sending out short summaries of, okay, we ran this test and it totally failed. Tell my boss. There we go. So there are jobs where it's almost 100% on the testing side. And then other jobs where it's 100% on the sitting at your computer and the analyzing data side. It very much depends on what you end up getting into. My job at TRC, I was almost 100% of the time in the lab. running the tests, and then somebody else, because I was just a testing engineer, somebody else above me was analyzing all the data and deciding where to go next.
All right, Jackson, question.
This is kind of two questions, but they're similar to each. Has your like perspective on vintage cars changed? Like when you see someone like bragging that I just spent like $500,000 on this old classic whatever, and you're just like, man, you just bought a $50,000 death trap. And on that same kind of note, do you kind of agree with the idea of like grandfathering in old cars that are really not safe?
You know, I at heart am just a car lover. And so I have to get past the little voice in my head that screams, this is a death trap, this is a death trap. You know, but yes, I sometimes struggle now more with the older cars. I've always had a dream of, you know, restoring some older car. My uncle used to have a Mustang, like a 1960 something Mustang, and everyone in the family always wanted to restore it and all that. Maybe I'm not as interested in doing that anymore, but I still really, I see the allure of that culture. I see the interest in automobiles and having a kind of a hobby like that to work on. And to some extent, I feel that they should just get exempted from a lot of, you know, any safety improvements besides having a seatbelt, because I believe that having a seatbelt, especially a 3-point seatbelt, is still the number one thing you can do to protect yourself in a car crash. So regardless of whether you are riding in a death trap or not, or a brand new car with all the bells and whistles, that is still my recommendation that people be mindful of wearing their seatbelts. But, you know, we've gotten some sports cars that have come by the office, and I'm the first person out there admiring it. I think we got in an Audi R8. Someone from Audi was visiting, and I heard them rev it, and I was like, I'm out the door. Like I was literally the first person out. One of the new Lexus vehicles, I can't remember what it's called. That one was coming around recently. We had Corvettes that came a while ago. So, I mean, I still am at heart a car person, and so it's a struggle. I probably wouldn't own an older car anymore, but I can definitely go to car shows and admire them.
All right, thank you.
Okay, so we probably have about 4 minutes left. Any final questions for anybody? I mean, from anybody? I see.
I got a quick question.
Yeah, go ahead.
Yeah.
Tyler.
So do you feel that you do more research within hardware or software of vehicle safety?
Right now, hardware. I don't know how that will change in the future, especially because a lot of these crash prevention systems or the level 2 systems are very software related. And we get the question often about, would we accept simulation data, computer modeling data? And the answer currently is no for the actual crash tests. But I think we're becoming more and more open to the idea of being willing to get information from manufacturers about these other systems that are so software based that we might be able to rate vehicles and stuff without actually having to test the vehicles themselves.
Interesting. Okay, anything else from anybody?
I have a quick question.
Yeah, dude.
So what car, if you don't mind me asking, what car do you drive?
I always get this question. And I'm always prepared. So I drive a Volvo, and it was one of the top safety pick winners back in 2011. So it was rated one of the safest vehicles on the road. It is a convertible because, as I said, I am a car lover at heart. So you got to have a little bit of fun in life, even though you want to be safe. It's one of the few convertibles that had a pop-up rollover bars to protect in rollover crashes. My husband also drives a Volvo S60, which is one of the top safety pick winners as well. So we try to keep that in mind when purchasing new vehicles. And usually, as kind of a coworker thing, when people get a new car, everyone's like, "So what did you get?" And then if it's not like, if it's a brand new car, it's one thing if it's used, but if it's a brand new car and it's some death trap, we're all like, yeah.
Yeah. All right. Well, Becky, thank you so much. Really appreciate your willingness to talk with us, and we certainly look forward to seeing you again, hopefully in August, like we usually do, with a new group of science and engineering students. Any last words before we sign off?
I think that's great. Thank you guys for coming and listening to me today. And anyone and everyone is welcome to contact me. So they can go through the professors to get my contact info. But if you have any questions about engineering, because usually in when you guys come, I hand out business cards to everyone. So if you have any questions about anything engineering or my career path, feel free to reach out. Happy Friday, everyone.
Thank you so much. We really appreciate it. Bye-bye, everybody.
Bye.
Have a good weekend. Bye-bye.
Bye.